will talk about object-oriented programming. And we will be covering all aspects of object-oriented programming from classes to objects to encapsulation, inheritance, polymorphism, and abstraction, the full circle of OOP concepts. Before we begin with this individual element, like what are classes, let's try and see why do we need these OOP concepts or what value do these OOP concepts add? So far, we have talked about basic data types. Then we talked about control statements, if else conditions, while loops, and so on. Now, and then we moved on to functions. We wrote a simple function which was to represent a calculator. And as you can see on the screen, we have a calculate function. It takes the first parameter, second parameter, an operator, and it does the basic addition, subtraction, multiplication, division. So all good and dandy. And if tomorrow I want to go forward and change and do some other operations on these numbers, then I am actually allowed to do so. So that's totally allowed. Now, seems pretty flexible. Why do we need OP then? Uh, to think about the usefulness of OP, we have to actually expand beyond the basic calculator function. We have to start thinking about more complex programs and more complex data structures. Now, for arithmetic operation, it was pretty simple because we were doing the basic calculator. It was not a scientific calculator, so we had two values here, the first parameter and the second parameter. Since we had only two parameters, it was very convenient for us to simply go forward and pass these parameters to the function call itself every time along with the operator and then let the function do its job. This function very well could have been static, which requires no dependency on its classes. And again, we're yet to come to classes, so nothing to worry. But it does not need any dependency on the context in which it is present primarily. It actually accepts all the inputs as parameter or arguments, and it can do all the computation and return the results. To understand OOP, let's start going forward with a more complex example. Let's say you are a home builder and you are trying to go forward and give out plans on the different layouts that you are going to have for the possible home choices for your customers. And we're going to start assuming that I am a new home builder. And let's so we'll be considering the example of a new home development. And as a new home developer, I'm actually selling different models which are going to be out there, and I'm going to be building a lot of houses. Now, when I start looking at these problems, I start thinking about is the in my problem, the homes that I want to actually build may have a function or a behavior which is actually called build. So that is possible. And it's going to accept a bunch of parameters to actually build the house. It's going to require some sort of square footage to actually build the house. It's going to require details about what kind of tiles were used inside the house, which rooms were carpeted versus not, what rooms were present on the ground floor versus not, and so on. So there are tons of elements that define how to build the house. It's not as simple as just taking two parameters, first parameter, second parameter, computing it. So I really can't pass it into each and every function that I have because I do have build function, but then there could be a bunch of other functions which are present. For example, the one of the function would be to actually start development. And the start development function may require leveling the ground based upon the territory which is allotted or what's my boundaries are. Then the next function could be all about making sure that the pipes have been put into place and they're present before I start actually going forward. And then it can actually start by building the exteriors only. Okay, so the build exteriors can be other function. Then it can have drywall installation as another function. So there are tons of functions which are present, but all these tons of functions may require common parameters that need to be passed to them again and again. And some of those parameters include is what's the square footage of this house, whether this house is supposed to have a brick exterior versus a vinyl exterior. What's the height of the ceilings that are present, or the height of the roof which is present in each and every floor? Whether the floors are supposed to have the hardwood floors or carpeted areas. So now what you're thinking about is more complex data structures. So you need to have a bunch of variables that actually store the values, height of ceiling, square footage, and so on. So there are a bunch of variables that are supposed to actually store the attributes relevant to the operation that you want to perform. And then you have a bunch of behaviors, functions, or verbs that need to take action on these attributes. And some of these behavior functions may go forward and update the value of these attributes. So you need a mechanism to expose some of these attributes to your exterior world, because after a certain operation has been performed, you may want to inform Mr. how it went. Um, so with functions, we achieved some level of reuse. The reason we started writing them down as functions was if we just write simple switch case statements, then every time I have a new variable to be passed, I have to copy paste the same switch case statement again and again. So with functions, I achieve some level of code reuse. But with now, as my problem statement get more and more complex, I'm seeing that I do have a need where I need to combine not only the functions, which are reusable behavior, but also the data structures. So I need to define my own complex data structures, and that includes the multiple variables that can be defined for that particular object. Plus, go forward and have a bunch of behaviors that can act upon those data elements. That's where your classes actually come into place. So now let's go forward and start looking at the classes and how they are useful. Let's go forward. Now let's start looking at what are classes. And we'll go into how to define them in Swift, but we'll start with what classes actually are. Now, classes are blueprints. Let's start by looking at the definition, which I found at billion.org, which I thought was pretty cool. In object-oriented programming, a class is a blueprint for creating objects, a particular data structure, providing initial values for state, member variables, or attributes, and implementation of behaviors. Now, that's quite a mouthful, but let's take some baby steps to understand what these classes or what this definition actually means. Going back to our example of the new home construction, as you know, each architect has blueprints of the house that they intend to make. So we're going to go forward and say that, okay, I intend to make a house and part of my drawing. So I'm going to make this house. Now I have a blueprint of this house. And the blueprint defines is, well, this house is going to have some number of floors, whether it's a ranch or it's a colonial, is going to define that this house has some square footage to it. Okay, that's good. It's going to define whether it has a master bedroom at the ground floor or not. It's going to define what's the number of bedrooms which are present inside the house. It's going to define the number of bathrooms that are present inside the house. So there are a bunch of parameters that are defined by the blueprint of the house. Then the blueprint also defines what kind of operations I can perform. For example, many times you go to a new home construction and you try and talk to them to move a master bedroom downstairs. This particular model just does not support having a master bedroom on the ground floor. You need to have the master bedroom on the second floor at least. So there are operations which are defined by the house model that has been chosen. So the build function, which if defined, would vary based upon what kind of a model it is. Each model is going to probably have a different build function. And then there can be other parameters defined. Is model allowed? And this is model allowed can look at the square footage of the house and the acreage of the land and try and see whether this house can actually fit in this particular space or not. So our classes are nothing but blueprints or templates which actually encapsulate not only the data elements but also encapsulate the behavior that is supposed to be present. So in terms of code reuse, as I pointed out, the OOP concepts are meant from code reuse perspective. What it means is that you are defining all your variables and you're defining all the function in one common place. And then you're going to keep reusing it rather than redefining it again and again. The simplest possible reuse that you can think of is that I go forward and start instantiating this particular class to actually create objects. Let's take an example. Now, in this house example itself, if we go forward and start looking at it, let us say there are a bunch of models which are possible, and the first model is Blyth. Now, if you're going with this particular model, what's going to happen is that you will go forward and instantiate your new home, and I'm going to call this new home, which is my template. So you're going to go forward and instantiate new home and then of course, initialize a bunch of parameters. And one of those parameters is going to be the model type, which is going to be Blyth. And you basically assign it to variable saying A, which is now my reference to this new home or the instance of new home. You can later go forward and let us say B represents the home which my neighbor is interested in. And you can instantiate new home again, pass it a bunch of parameters. Maybe he's not interested in Blyth. Maybe he's interested in ranch. So it goes forward and instantiates a ranch. The point is that since the template new home was defined, in both cases, I didn't go do anything to the way these data elements were organized or the way the behavior for these data elements, behavior is going to be executed on these data elements. All I did was I went forward and instantiated these objects from the class by having it say that it's a new instance with specific value to the properties that I had already defined. Now, the difference between class and object again is that an object is an instance of a class. And can't emphasize this again, so I'm going to repeat this. An object is the instance of a class. What it means is that A is an instance of a new home class, new home being the blueprint. B is the instance of a new home class as well, B and new home being the blueprint. But both A and B are not same. A and B are different. They are two different instances of the same blueprint, just as you would imagine in a car example. So we're gonna take another deep dive with a car example to make sure things are very clear. Let's look at the car example. I am actually going forward to go forward and try and define a car. And let's assume that I'm going to go forward and define a very generic version of a car. So I'm going to start with a blueprint of a car. And the car is very basic. It has got a bunch of variables, which are going to be the attributes for this particular car. And it will define is the number of doors which this car has. And it will also define is whether it is convertible or it's a sedan, whether it's a SUV. It will also define some basic functions upon these cars is, for example, drive. Okay, it's gonna go forward and drive the car. It has a brake function so that I can actually stop. It has probably an accelerate function. Okay, so it is going to have functions which are available to do the basic operations. Now, as things get complicated, now I remember that Henry Ford once said that um, consumers can have any car as long as it's black, and that's all good. I had a basic car class. It defined the attributes and it defined the behavior both. But down the line, consumer thought, okay, I'm not very happy with just one particular kind of class or car. I am actually want some variety. So then came multiple types of cars. So now I start looking at and saying that, okay, well, I have cars which are present, and there's a basic car, but then there is subdivision of cars. Like there is a car which is going to be gas powered cars, and there are electric cars. The gas powered cars actually have totally different implementation of how the brake actually occurs, how the acceleration actually occurs, and how it is refueled. Okay, so there's a function to refuel the car, and that's behavior is totally different between a gas powered car and electric car. Now, within the gas powered cars, there are other set of variations which are possible, and those can depend upon whether the gas powered car is going to be four cylinder or it is six cylinder. And same thing with electric cars, could be depend upon how many battery units there are. But if we skip that, down the line, there are variations which are available based upon whether it is a pure electric car of type Tesla or it's a hybrid kind of a car like Prius or it's something like a Leaf. So all different cars, but then these cars tend to have different implementation of some of these functions. And the reason I use the word some is because at a very high level, the car class, of course, tells you that whether the car can be refueled, how to brake, accelerate, and drive, but electric car have totally different implementations. Now, between Prius and Leaf, their braking acceleration may be following more or less the same structural logic or same behavior. Or at least the electric cars may use the same set of properties to store the values, like what kind of a battery it is. While the gas powered cars may have totally different behavior, like what kind of horsepower engine is actually present in there and how often the engine oil needs to be changed. So all the behavior can be encapsulated in the gas powered cars. Now, going back to our example, we have this class car and we can instantiate the objects of the car. But I can go forward and instantiate objects of any one of these elements differently. So I can go forward and instantiate the objects of gas powered cars or an electric car. I can even go forward and instantiate the objects of a car like Tesla. So my objects at any given point in time represents an instance, and the implementation actually defines whether these instances are from the same blueprint or a different blueprint or a parent of that particular blueprint, or do they have the same parent or they have different parents or they're totally different classes which do not have any commonality between them. But as you define a class, all you are trying to define is how does the blueprint of that particular class looks like. Classes by nature, and if you're trying to conceptualize a real system and trying to solve the real system in a program, they represent the nouns that are actually present. And you can start thinking of them as car itself is a noun. A car may have an engine which is present inside it. And the engine is an attribute for the car, for sure. But then engine itself is a noun. Engine can be a separate class altogether. And the reason why this is important is because you are trying to separate the attributes and behavior into these logical pieces of of objects or nouns, which can encapsulate not only all the attributes that are required to define that particular item in the process or in the system or the product, but also the behavior that can actually occur on that particular product or item. For example, for engine, you need to understand is that how can we actually go forward and service this particular engine. Now, car, knows that it has an engine, and engine knows how to service it, so car doesn't need to worry about it. As a result, if I went forward and defined my car, and then went forward and defined my gas powered vehicles with 4 cylinder and 6 cylinder, and then I can have further subtypes which are available based upon the models, which can it's a Toyota, or it's a GM, or it's a Ford. These classes of cars may internally be using the same engine. And here I would like you to take a step back and see, in the real world, that's how most of the systems are actually built. It's not that a single product manufacturer, like a car manufacturer, is built making end to end everything on their own. They buy a lot of items or subcomponents from third party manufacturers, and then they would go forward and assemble all those components to make the final unit. So as you go forward and define your class or your blueprint, you see what are the subcomponents which are involved, and then you have a dependency or you include them as attributes, but the blueprint for those subcomponents are defined outside. And with this, you can have multiple blueprints or your classes basically refer to these common blueprints of these components that form to make your objects, hence achieving a higher level of reuse. Now, if you're using different attributes, like in this example of engine, then these are just attributes that are used, but you're achieving a good amount of reuse, which is the purpose of object-oriented programming. But at the same point in time, you are inheriting a lot of behavior from your parents. Like here, gas-powered cars inherited the behavior from the parent class, which was car. And then the 4 cylinder vehicles actually inherited the behavior from the parent, which is gas powered vehicles, and so did the 6 cylinder vehicles inherited the behavior from their parents. Now, let's go forward and look at an example of how we go forward and define the classes and objects.
Okay, let's start by seeing how we would define a class and objects in Swift. We start with the class keyword, as we have to clearly identify that what we are going to, the new type we're going to define is of type class. So we're defining a class which is new home, and it's going to have some attributes. The attributes which I'm defining are square footage, which is going to be of type integer. I also would need to know is what's going to be the price of my new house, and it's again going to be type integer. I'm not going to worry about going to decimal points. I'm not gonna nickel and dime a customer from buying in a house for a few $100,000 and then paying few cents. So it's going to be of type integer. It's also going to have an attribute for model type. Now, model type is going to be important because model type defines how exactly the house is going to be built. So I have went forward and defined my class and its new home, and it has got a bunch of attributes. I'm getting a compile time error because all the attributes I've defined are not optional, they are required variables. And since they are required, I must initialize them before use, which in clear definition of a class means is that before I instantiate a class, those variables must be initialized. So I need to do so inside the constructor or the initializer of the class. The init method, which starts without the func keyword, which is used to define functions because it is the initializer, so it's just very unique function, goes forwards and initializes this object. So I've defined the init method, I pass the square footage, price, and the model type, and it goes forwards and instantiates new home and gives me back a reference. Um, Now I have got all my variables initialized. What I'm seeing is that I've defined the class, I defined the initializer, but no real execution of the class has taken place. And the reasoning is because the class is just a reusable piece of functionality where the data structures relevant to the behavior or the functions are combined together in one unit, but I have never invoked it. And the way I invoke is that I first go forward and instantiate the class. I call the initializer, I will not call the init function because I need to define who's in it. So I say new home. I could have called new home.init, but that's redundant. I just call new home. That's a shorthand notation. And as soon as I say new home and pass on the right attributes to the initializer, I have now got the object reference with the right attribute values as passed in initializer populated and assign it to the variable home. I now go forward and uh, define a second variable second home and assign it to the home reference. What I see is now for a second home, I took the price of my first home and added $10,000 to it. Now, when I try and inspect these variables, what I see is that my first home is still at 250K, but my second home is supposed to be at 260K, but in reality, my first home is also in 260K. I had only bumped the price of my second home to buy $10,000 to the price of first home. So why did both homes ended up with 260K price rather than second home be 260 and the first home being 250? And the answer lies in the fact that these objects are passed by reference. So we're going to dig into this a little bit more. Let's go forward and define the third home right now, but we'll define it by using a totally new initializer. And I'm going to assign it value 280K. I'm going to look at the values in the results pane, and I'm going to see the third home is 280K, and that doesn't reflect any changes in the value of the first or the second home because it's a separate object, it's a separate memory reference. And this is one topic which we should definitely take a deeper dive into. And what we're going to do is that, okay, we're going to look at is when I defined my first home, I simply went forward and assigned the value 250K, but that resulted in a memory being allocated, and in the memory the value of 250K be stored. When I did the second home assignment, I just simply pointed to the same memory we used by first home. As a result, both first and second home are pointed to the same memory location. And when I change the price of the second home, I'm essentially changing the price of the same memory location, which is also referred by the first home. As a result, as soon as I change the price, the second home reflects the new price, but the first home also reflects the new price. Now let's take a deeper dive into this one and see what's happening under the hood. When we go forward and instantiate an object, then a certain portion of memory is created and allocated for that particular object, and that's what we are showing to be happening right now. Now that's for my class new home. When I went forward and invoked the initializer for new home, a memory got allocated for new home, and this memory location, the reference to the memory location was passed to the variable which was referring or which called the new home initializer. In our case it was home. Inside the memory itself, all the attributes which are defined by the class are going to be stored. And for our conversation, we're just going to assume that the memory reference is 0x010, and in there are values which are stored for price, there are values which are stored for square footage, and there are values which are stored for model type. Now for all practical purposes, there will be more attributes that are defined and more memory allocation that could be happening, but for now let's just assume that's the case and the rest of the attributes just follow on. Now let's look back into the code. When we go back into the code, we see line number 14, home is doing the initializer for new home, and that's where the memory 0x010 is actually created and handed over to the variable home as a reference, saying that okay, fine, the object is created and here's where memory is created, and you can go forward and refer it. So now let's just type it out. Let's say var, and we'll say that okay, our variable was home and it's now pointing to the memory 0x010. That's where our object is basically stored. Done. Now later down the line, for my second home, I decided to go forward and define a second variable, and the variable was second home. So let's write it down. And for initializing, I assigned it the same value as home. But when I did the assignment, what really happened was the home's reference to the memory where the object was stored was handed over to second home. The second home is also going to be pointing to the same memory location, which is 0x010. Again, this is a very important concept. When I did the assignment, unlike structs which are passed by value, it wasn't that all the attributes of home were copied over to a new memory location, a new object, and handed over to second home. It's just the same memory location was passed on to second home. As a result, both home and second home are now pointing to the same memory location. So line 16, when I go forward to the second home and bump the price by 10k, what's really happening is that second home is going to the memory location where the price is stored, is retrieving the value as say 250k or the current value and bumping it by 10k. So the new value is 260k. So second home goes forward and updates the value inside the memory to 260k. The first home is also pointed to the same memory location. So later down the line, when first home comes in to retrieve the price, then it's also going to get the same value back for the price because it was pointing to the same location in the memory where the original value was stored as second home, as the value which was updated by second home. So home, when it's referencing, it's basically going to get back the same values, and that's exactly what we are saying. But when we go forward and initialize the third home, there I use a new initializer. When I use the new initializer, at that point in time, the initializer is actually going forward and creating new memory location and reinitializing all the attributes, hence the name initializer, is reinitializing all the new variables and then going forward and storing them in a totally different memory location. So I went forward, defined the variable third home. I call the initializer on the new home as I'm showing right now. And then it actually went forward and created a new memory location, which will also have the price, the square footage, the model type, and bunch of other attributes. It has a totally different memory location, and for our conversation purposes, I'm assigning it the value 0x020. So it gets a totally different memory reference where the object is present. Now, when the third home goes out and tries and update the price or square footage or model type, anything it likes, it's going to do it on OX20, which has no relation to OX010, which is being pointed by home and second home. So any changes to third home are not going to reflect across any changes to home or second home, but any changes in home will reflect.
And tie out the loose ends. We just saw that we defined our class, and after defining a class, I went forward and instantiated my new home class. I got the object reference so that I assigned to a variable named home. Then I went forward and defined a second variable, second home, and assigned it the reference which is used by the first variable. And as I went out and changed the price of my second home, the price of my first home also got altered. Now, this passing by reference can take some time for some of the developers to understand. So let's try something visual. What happened here is that I do have a template that is present for my class home or the new home. Now, when I use the template for my class new home, okay, all I am doing is by calling its initializer, and we're going to get to the initializers. You have seen the initializers. These are the init blocks. But by using the initializer, all I have done is that when I do a new home, I create a new instance, or I go forward and initialize inside memory all the attributes that are defined by new home for certain specific values. So this is my memory location, and for the purposes of this conversation, I'm just going to say that it is 0x010. But this is the memory location, and inside the memory, it's holding the price of the new home. It's holding the square footage of the new home, and it is holding for sure the model type. And of course, it can have other attributes and function types defined and so on that will keep going on. But the thing is that as I did call new home, at that point in time, I passed it some initialization values $2,300, $250,000, and model type of blade, and went forward inside internally. It went forward and initialized this and assigned some memory to it. And the memory location where this object or the object created from the blueprint of new home is stored is returned back as the memory location where it's present. Now, when I did that and I said home, at that point in time, all I got back is the memory location where the object is present. So I am getting a reference to where actually the object is stored in the memory. Later down the line, when I defined where second home, at that point in time, I assigned it to home. But home was not the object. Home was the reference to the location of the object. So as a result, what we got back here is the second home getting the value of the memory location where the first object had been stored in memory. So both home and second home now point to the same memory location. Later down the line, I went forward and changed the price by calling second home dot price. But when that action was taken by second home for setting the price, at that point in time, the price was changed in the memory where it's present and was bumped up from 250K to 260K. But since second home went forward and bumped the price to 260K, the first home itself is pointing to the same memory location. As a result, if you try and retrieve the price of the first home, it also gets bumped now to 260K. Now, this is what we call as references. And in functions, you will also talk about pass by reference. But in later down the line, I went forward and from the same blueprint, initialize third home. So I defined my another variable and said third home. When I did initialize the third home as new home, at that point in time, what happened is, and sorry if I was not sharing my screen. At that point, what happened was that now, since you are doing the reinitialization, somewhere in the memory, another initialization is done for the object, and space is allocated. Now, where this allocation is done is not controlled by you. But let us say this time around you got 2x020. Now, third home gets the value 0x020, which is different than 0x010 because this time you call the init method again, resulting in new memory allocation. And as a result, any changes you do on the third home will not reflect on the first home itself. And that's exactly what we saw. Now, coming back to our example, there's one additional thing which we would like to cover, and that one is primarily around the initializer. Um, I went forward and defined the initializer, but I didn't go into details about why this method is so special. First of all, here, when I'm instantiating the object as home, I'm actually going forward and calling new home, passing it a bunch of parameters, but there is no new home function which is present inside the new home class template. It's just not there, but I'm able to call it. Why so? And the reason is that each class can have an initializer. Actually, it can have multiple initializers. And the initializer is defined by the word init. What it means is that if the function is the initializer of the class, then it's assumed to have the same name as the class. And that's what you see here. You're just replacing the init with the new home, and then rest of the arguments you're passing as it is. When you call the initializer, that's when the actual object creation is done. That's when the memory is allocated and the attributes are initialized. So that's where the magic is actually happening. And at the end of all that execution, home is getting the reference to the object for usage later down the line. Now, the question which of course arises here is that, well, I get that, but do I need to have all my attributes defined in the initializer that I have defined? Can't I simply go forward and have a dummy empty initializer? Well, you can't. As you will see, you get these compile time errors because you're not using optional attributes. You're using normal variables, which means that the variables must be initialized before usage. And here you are initializing or instantiating your object, but the variables have not been initialized, and that's a no-no. So that's not going to be allowed. So you need to define initializer that goes forward and initializes all your variables and constants, but you can skip optional variables. You don't need to necessarily go forward and initialize them. Okay, all good and dandy. Now, how is this different from structures or structs? We have worked with structs in the past. Seems very much like a struct. Are there any differences? And there are a few. So for demonstration, let's go forward and first change the keyword class to struct. As I do so, and I change the variable from class to struct, you observe a few things. Number one is that there are no compilation errors. It works. Right? It's nothing that I'm doing is so special right now that classes and structures would deviate. So it's all good. Another thing that you will notice is that if I go forward and look at my second home and the home or my first home, the price is now different. While in the example of classes, and I'm going to show that again, if I revert it back to class and have it run, the prices remain the same, 260 and 260. But if I change it to struct, the price basically is now different. The second home has a new price, but the first home has 250, and why so? And the reasoning here is that when you pass around a struct, in the initialization on which we did on line 14, and then we did the assignment to second home on line 15, structs are always passed by value, never by reference. So here, when you went forward, and let's look at our example once again. When I went forward and did this assignment again, but this time with a struct, it's not going to have the memory, it's not going to pass on the memory reference like 0x0100, but what is going to get you is a copy. It's going to take whatever was present on the first, for the first object home, and it's going to create a copy, and the copy is written back to second home. And since what we're getting back is the copy, any changes you make to the copy are not going to be reflected to the original reference. As a result, as I change the second home price to 260K, the original first home price remained 250K. Important point to note. Structs are always passed by value and never by reference. Um, Next on, the next important point to note is that structs get default member initializers, which means is that I can go forward and remove the init altogether. I don't need the init. And as I run it, I still get the same results. I don't have the init, but when I call home and try and initialize it, it does not complain. It simply goes forwards and accepts that, okay, fine, new home, and I'm passing it initializer with all the attributes that are defined in struct, and it just simply works. That's because structs create a default member-wise initializer. This is called a member-wise initializer. It has all the members that are present in the struct that are non-optional, and you can go forward and initialize them. That's created by default by struct. You don't necessarily need to define it. While if you try and do that on a class, that's not there, so you get a compile time error if I change it to class now. So structs get default member-wide initializers and classes do not. I'm going to put the init back so I can keep toggling between struct and classes. Now, these are the two main differences that we should always keep in mind. There's another difference between structs and classes, and that is something that we'll cover when we come to the topic of inheritance. Structs cannot allow or do not allow for inheritance. Structs do not even allow for dynamic dispatch or what we known as compile time polymorphism, while classes do. And all those topics will be covered separately. You can refer to other OOP lectures to understand how compile time polymorphism or dynamic dispatch works. But for now, the two main differences you should be aware of is first, structs create a member-wise initializer by default for you. Structs are passed by value, while classes are passed by reference. And that's critical because if you make accidental changes to a variable you actually did the assignment on, those changes are going to be reflected in the original value as well. Another item which I generally get asked is, well, we have an initializer and we went forward and got the memory created for this object. Now, when is this memory getting deallocated? Now, you don't have to worry about going in and doing some additional steps like releasing the memory to actually have an object deallocated, like you had to do in Objective-C, original versions of Objective-C. ARC was introduced for Objective-C starting from iOS 7 onwards, so that's already taken care of, and you never had to worry about those things. Um, Similarly, for objects, you don't have to worry about deallocating objects necessarily. That's already taken care for you as part of the arc, and the arc has been explained already in a separate video. I will provide a link to the same and the description of this particular video itself. Um, but we do have a DNA init method. And the purpose of the DNA init method here is to simply go forward and release some memory handles, like if you're talking to a database or to certain files, and you want to make sure that that handle is now released, you can do so by the DNA init method. And this is useful because you don't necessarily know when object is going to go out of scope. And you also don't necessarily know that if the users have a conditional check on their end to make sure that something gets executed always on the end of completion of a block or something. So there may be some resources that need to be released like files or DBs that you can actually go forward and put in the dinit block and then go and release them. This is not a commonly used feature of Swift programming for iOS purposes, but if you were actually using it for server side, then it has a bunch of use cases where you can use the dinit function. Um, Another item which we can be curious about is that I defined those attributes, and all those attributes like price were available for me for usage. I can do a get on them, I can do a set on them, it's equivalent to doing get and set. Um, so does it mean that for everything get and set is created by default? And yes, if you don't do anything, then by default every variable will be a get and set, and they will be you will be able to access them. But you can restrict access, and we'll talk about this more when we talk about the topic of encapsulation. They will go into the details of how we can actually restrict restrict visibility by having just the sets or just the gets, and how can we actually introduce even computed properties. So more to come on that later. But from these classes and objects, the main things that I want you to take out is, first of all, classes are actually passed by reference. So you use the initializer to actually create the object. And what you get back is a reference to the object and not the full object itself, but the reference. So when you do the assignment of one variable to another, you are basically going forward and you are assigning the reference. So any changes your second variable makes to the object itself will be visible to the original or the first object as well. The initializer does not use the name of the class, it uses the keyword init. It does not start with the func keyword like other functions. It does not have a return value, anything that is specified, but um, it's assumed to be always the same name as the class. So when you invoke it, you don't invoke it as an init, you invoke it by the class name, and it's assumed to be the init function which is getting, or the initializer which is getting invoked. And that's all you need to know for classes for now. But the OT concepts for encapsulation, inheritance, abstraction, polymorphism will continue.